Okay, okay, so I think we have a couple things to do for this lab. One is to talk about the pre-lab. So there were some calculations. There was, there was a question about why the mass decreases. And then there was the last question, which really addresses how everything fits together. So we should talk about the pre-lab, understanding the procedure and the strategy we're using in this lab so that everybody's on the same page. Now that may be a little faster for some people than for others. And so my thinking is that we'll go over some of it together first. And then for people who need to talk longer and to really understand how the pieces fit together, because it's confusing procedure, those people maybe will go into a breakout room. Then we're going to do the lab. So let's see, 1 is the pre-lab, 2 is the lab videos. Did everyone get a chance to read the lab itself? It's probably best to take some time now to do that. So I'm going into where it says lab 5, the information for lab 5. So inside the lab 5 section that's on the calendar for today, we have the instructions that chemical reactions are due, and that I just wanted images of the lab pages, ideally as one file, but if you need more, I put extra file things inside the assignment, so it's right in the same place when I'm grading. Okay, so this lab, the stoichiometry lab, has 2 parts. In part A, we're going to do a reaction, and we're going to decide which chemical equation governs that process. We have 3 choices, and we're going to figure out which one governs a process by measuring how much we start with of sodium bicarbonate, and then we're going to measure how much CO2 gas is lost. So this is that gas evolution reaction, and the CO2 gas goes away, it goes out of the solution, and from that ratio of masses, we calculate moles in the pre-lab, and we get that mole-mole relationship. That mole-mole relationship is going to help us decide which equation governs the process. So I say in here, check with me before you move on to part B. So usually I ask students to complete all of their calculations in lab before they start part B, because everything depends on your choices. So I want to ask you to do those calculations here in lab with us together now in the lab session, and then we'll go on to part B and you'll take that data. Now a lot of times part A will take people hour and a half, the whole time basically. And then at the very end I say, here's your sample, just take your data. And they finish the end of it in like 10 minutes. So it's worth taking some time to really understand what's going on in part A. And then in part B, we're going to pick our reaction from part A. We're going to pick that reaction. And in part B, we're going to use that reaction to verify the claim on the label. So the label of Alka-Seltzer says it has 1916 milligrams or 1.916 grams of sodium bicarbonate. We're going to find out how many grams do we think it has. So we're going to do an independent verification. We're going to figure out if the label, how true is the label? How close are we to the label's claim? So that's how it all fits together. So we're going to do part A one way, and then we're going to use the results in part A to figure out part B. There's some language about how to weigh things to get this. And you can see I drew a little diagram. In the lab video, I weigh out how much sodium bicarbonate I have to start with, and then I put it all together to figure out how many grams of reactants I have all together, including the glass. Then I'm going to put the bicarbonate into the acid that reaction we just worked on is going to happen. We'll see fizzing. So that carbonic acid would form, except that it immediately decomposes. The carbon dioxide comes out of the reaction and it escapes as the gas. Then we're going to weigh it again after, and afterwards it should weigh less. And the mass that we lost is due to the carbon dioxide. All right, so in part B, you're going to use that reaction you picked from part A to determine how much sodium bicarbonate was in the tablet. So I left in some procedure notes. So when you add sodium bicarbonate into the acid, you have to add it slowly. Sometimes students will dump it all in and it'll go out over the spill all over. And then you just have to wash everything, dry it, and start over again. So you'll see I'm a little bit careful about how fast I put that in. And you have to complete the calculations in part A. And then usually I sign the notebook or I just give you your tablet. You don't get to have your tablet until it's complete. And then, only then, can you start part B. And then one of the things that happens is students don't know for sure when the reaction is over because there's some white stuff and that white junk, and I show you in the videos when you see that white stuff left in there, that's what's in there to keep the tablet in its shape and not just be a powder. So there's a pre-lab calculation. It's very similar to the paper, but it's its own assignment inside WAMAP where you have to enter your answers. And I did put a sig fig point on there, a sig fig requirement. So if your sig figs are wrong, it will mark it wrong, but I'll probably go back and give you at least half the points or more. But that's why maybe it marks wrong. And then we're going to use that mole-mole relationship. So moles of sodium bicarbonate to moles of carbon dioxide. And that's going to tell us which coefficients in the equation give us the right process. All right, I did make a little bit of changes for what we're doing online, which is why the pages start at 1 again. So here is a lot of background. It's very helpful. It's a good idea to read. We're going to use the balance equations, and then this is the mole-mole relationship I'm talking about. For that equation above, this is the mole-mole relationship. Do you see where that comes from? We have 3 moles of H2 for every 1 mole of N2. We're actually going to look at the products, right? We're looking at carbon dioxide and sodium bicarbonate. But this kind of a relationship, that mole-mole relationship, is what we're going to build. All right, so here are the choices in our reaction. This is our choices when we do the lab work. So for today, you have to choose which one of these, A, B, or C. Which one of this describes the process? Now, maybe you know the answer because we just did it in class, but you have to show with your data how you know that answer. These are the mole-mole relationships we're talking about. Is it 1 to 2, 1 to 1, or 2 to 1? So that's the choice. We're going to take our data, we're going to construct that mole-mole relationship, and then we're going to decide which reaction governs our process. Then we're going to use that reaction, and from it we're going to take one of these relationships and use it to calculate how much sodium bicarbonate was in the tablet. Now what we're going to do in the lab is we're going to take the mass of the reaction before minus the mass of the reaction after. So we're going to look at that difference. And then there was a little bit of a change I had to make to the procedure in this part because I couldn't put it all together on my little scale. I had to do just one part and then the other. So I updated our data tables to reflect that. Okay, so this is the procedure. This is the pre-lab. So this is where you're going to have slightly different values. So just work with what you have on WAMAP, but it's exactly the same type of calculation. And then for this one, we're looking at, look at that, it's calcium carbonate. So that's a different compound. So the pre-lab is different from the post-lab, from the lab experiment. We're going to work with sodium bicarbonate, but in the pre-lab, we're going to talk about calcium carbonate. So you're going to calculate this for calcium carbonate, and then from these moles, here you have moles of calcium carbonate, moles of CO2, you're going to use that mole-mole relationship to figure out which one of these it is. Is it 1 to 2? Is it 1 to 1? Or is it 2 to 1? Which reaction governs this process based on these masses that were collected here? Okay, so you should be able to go into WAMAP and click on the pre-lab assignment and answer these questions. So go ahead and go into WAMAP and work on that pre-lab, and if you have questions, let me know. You do get to submit it multiple times, so let me know if you need help. Okay, so some people are stuck on the last one, and that is usually the hard one. So there was a question about carbon dioxide. So let me take a look at this one. Okay, so but we're looking for how many moles of CO2, right? What are we starting with? Everybody has a different number. You talk about part 3. What is the relationship that you got with those? So then what did you do with those values? Talking about the answers that you got, what do you do with those answers to pick the reaction? You want to construct something like moles of calcium carbonate, moles of CO2. And so for your values, maybe we got 0, 3, 3, 3. I'm just making something up. 0, 3, 3, 3, or maybe it's 3, 3, 2, a little different, I don't know. And then if you just put those numbers in, we have to figure out, is it closer to 1 over 2?
1 over 1.
1 or 2 over 1. So we're trying to figure out what the coefficients are. I have a little bit more I want to tell you as a class, and then we can move on to taking the data. And that is, I'm going to scroll down a little bit. In the video, I had to split this part up. So I have the mass of the beaker and the acid before and after, and I have the mass of the watch glass and the sodium bicarbonate before and after. And so I'm going to have to add these together, right here. That's going to be our total mass before the reaction. We have to add that together. And then I did the same thing after the reaction. We're going to have to add those things together for after the reaction value. That's the change I had to make because my balance wouldn't hold everything. But we can still do the same exact procedure. It's just we have to add those as two separate things to get the total. And we have to add these, the two separate things, to get the total. And then we're going to take, so to find the difference, we're going to take this one minus this one, the total. You're going to take that whole, after the reaction, that total, and subtract it from the before the reaction total. That'll get you the mass of gas that is gone. There's a little bit more. And that is right here, from here to here. We measure the CO2 that came out of solution, but some of the CO2 stays dissolved in the water. And we know how much that is. That value for 50 milliliters, these are both 50 milliliters of aqueous solution, and that means that a small amount, 0.002 moles, stay in the water. So we're going to correct our values with that amount because it just works better, right? There's some CO2 that stays in there. So when we go from this line E to this line F, we're going to add that value, 0.020, because that stays dissolved in the water. It didn't bubble out, it stayed in there. Okay, now in part A, where we're determining that mole-mole relationship, just like in the pre-lab, we are going to use this mass and we're going to calculate this. Okay, so this number here comes from this number here, right? We know how much we started with. So we calculate moles, and that gives us the relationship. Then we're going to use that relationship to pick the reaction. So you'll have to pick reaction, A, B, or C. Which one is the right one? Using your data. So you'll have three different relationships, right? You're going to compare these numbers with these numbers. Are they 1 to 1? Are they 1 to 2? Or are they 2 to 1? And then you're going to pick your reaction and write it right here. Then, as we go to part B, this one works differently. We're going to do the same thing, and I show you the label claim, so make sure that you write this down from the video. This is from the packet. And then as we go through these, we are going to measure the mass released, and then we're going to correct it with that 0.002 moles, and that's on this page too, right? We have that same correction. And then we get experimental moles. We're going to go from the mass to the moles, and the moles to the corrected moles. And now we're going to go to, from this number of moles, we're going to use the relationship from part A to calculate how much bicarbonate was in there. And then from that value, we're going to calculate the grams that must have been in the tablet. Then we'll compare that to this value. So it's different. Part A and B are different. Part A, we're going to find that relationship. In part B, we're going to use that relationship to calculate how much bicarbonate was in that tablet. So this is where the videos are located. I'll go ahead and click to there. So here we are, Stoichiometry Part A, Trial 1. So you should have your data tables laid out and ready to take data, because I say it verbally what those masses are.